Okay.
Sir, attendance වලට මේ OTP එක මොකක්ද?
මේක නේද 36යි 57.
සර් පේන්නේ නැහැ ස්ක්‍රීන් එක.
පෙන්නද ඔන්න ඉන්න. ස්ක්‍රීන් එක පේන්නේ නැද්ද? Now can you see? Now can you see this? Because you need this verification code also. Okay. මේ verification code එකක් තුන. නැත්තම් පේනවද දැන් ස්ක්‍රීන් එක? දැන් පේනවද ස්ක්‍රීන් එක? පේනවනේ. හරි. එතකොට මේ OTP code එක මේක 3657 මේ verification code එක වෙනස් වෙනවා තප්පර 5න් 5කට. හරි. So can you see this two homeworks question I gave you? So I gave you two questions. I gave you two homework questions. Okay, I hope you can see my old screen. Okay, so this is the first question, homework question. Okay, so this is a complex exponential signal. Sorry, not complex exponential signal, exponential signal. And so this is a continuous time signal. And you need to sample this signal with 100 Hertz sampling frequency. Okay. And the second question is, okay, this is the first question. Okay. And the second question is, you are given a sinusoidal signal. Cosine 45 40t. Okay. So you are given two. So you need to first sample this signal with 80 Hertz. Then you have to sample this signal using 160 Hertz. Okay. Then you have to write, you have to draw the discrete time signal, discrete time signal. If this is x1, if this is x2, you have to find x, you have to find right x1n and x2n with 80 Hertz and x2n with 180 Hertz. Okay, so this is the homework. Okay, so you are given. Okay, so I hope now you have finished your attendance marking. I think you got my 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 6 are there. 6 are there. Okay. So can you see the screen now? Can you see the screen? So actually
Yes,
this
sir.
one, okay, thank you. Okay. So actually this one is an exam type question. Okay. So in your final exam also, this kind of question will come. Okay. This type of question will come. Okay. Okay. Now we will try to do this question. Okay. So I told you that, okay, so we are in sampling. Okay. We are in sampling process. We are studying the sampling. Okay. So if we are given a continuous time signal, normally referred in time. Okay. So we are normally referred this signal in time. Okay. So you can you can sample this continuous time signal and you will get a discrete time signal. Okay. So discrete time signal is normally denoted in n. Okay. So then this n is the number of sample. This is the sample number. This n is the sample number. This n is the sample number. Last week we have discussed this. Okay. This is sample number. Okay. And there is corresponding time value for this sample number. Okay. So let's say that sample time, if the sample time is Ts, Ts can be equal to n Ts. This Ts is the sampling time. Sampling time. That means time taken to get one sample. Time taken to get one sample. Sample එකක් ගන්න ගත වන කාලය. ඒක තමයි sampling time එක. Okay. And if you get 1 over Ts, this is number of sample per second. This is number of sample per second. Okay. And we normally refer this as Fs, sampling frequency. Sampling frequency. Okay. So we have learned these things. Okay. We have learned these things in previous week. Okay. In previous week. Now we are going to do some example. Okay. So these examples. So these are actually, this one is exam type example, and we will do 1 or 3 more examples using this this method. But first you should understand what is sampling and how we can draw the sampled signal. So it is very important. Okay. So now I will get the first question again. Okay. So that is xt is equal to e to the power e to the 5 e to the power 5 e to the power minus 3t. Okay, 5 e to the power minus 3t. Okay, so so now this is a continuous time signal. Okay, so if we draw this signal, what type of signal we get? Can anyone remember? This is a exponential signal, normally referred as negative exponential signal. So how you draw this signal? Okay, so you have to put some value for this t. Okay, so this is the independent variable t, and there are the independent variable can get any value. Okay, can get any value. Okay, so if you add, if you give some value to this, so you can select some time value. Okay, some time value, and you can calculate the amplitudes with respect to this time value. Okay, with respect to this time value. For example, I am taking the t is equal to -1. Okay, t is equal to -1. Okay, now I am getting 1 point. T is equal to -1. Okay, so that means x minus 1 I am going to evaluate. So it will be 5 e to the power minus 3 into 1. T is minus 1. Now I can find this value. Okay. So can anyone tell me this value? Okay. Using a calculator. I will use MATLAB. Okay. I will use MATLAB to calculate this. Now I think you are familiar with MATLAB. Okay. Because in signal and system, you have learned the MATLAB. Okay. How MATLAB can be uh, used to demonstrate the signal processing work. Maybe you have learned them already. Okay. So I will use MATLAB. Okay. Are you familiar with MATLAB? Because one MATLAB assignment also will be there. Okay. So you should be familiar with the MATLAB. Okay, meanwhile it is loading. Okay. So you can find this value. Okay. Then you can find another value. Okay. For example, you can find x equals 0, t is equal 0. When the t is equal to 0, okay. When the t is equal to 0, you can find x0. So that will be 5. Okay, so you can take 0, okay? Then e to the power minus 3, t is 0. That means e to the power 0. So you know what is e to the power 0? It will be 1. Okay, so this will be 5 into 1. That will be 5, no? Okay, so when t is equal to 0, this value, this xt value will be 5. Okay, and you can find when value is minus 1. Okay, so that will be 5 e to the power minus 3, sorry, plus 1. Okay, because minus 1 we have already find. Okay, so plus 1, and using a calculator, using MATLAB, you can find these values. Okay, for example, if I use MATLAB, okay, 5 e to the power minus into minus, it will be plus. Okay, so e to the power 3. Okay, so I can write it like this: 5 multiply. Okay, so I'm using that equation in command prompt. Okay, so I can get the value directly. Okay, exponential. So this is x, how we write t. Okay, this is e. This exponential means e. Okay, so and I need to write this subscript. Okay, so it will be minus 1 minus 3 into minus 1. That will be plus 3. So if I put plus 3, then I can get the value. Okay, so this is the value, 100.4271 kilometers. Okay, it's a big value actually. Okay, so it will be around at minus 1. Okay, at minus 1, at minus 1, it will be around 100. Okay, it will be around 100. Okay, so this xt is equal to 100. Okay, so maybe it in 0.5. Okay, it is less than 100 definitely. In minus 0.5, I can write it in the same manner. So it will be 1.5. No? If I multiply 3 by half, it will be plus 1.5. So it will be 22. Okay, so this point will be 22. Like this. Okay, so this value will be 22, and when t is equal to 0, it will be 5. Okay, so you can see that it is somewhat like this. Okay, and if you want to find minus 1 value, so that will be minus 3. No, sorry, +1 value, +1 value. This is plus, okay? These are plus, I'm sorry. These are plus, okay? 1, 2, 3 plus value. If you want to find plus value, +1, it will be 3. 3 into 1, okay? So what is the value is, that is 0.24, okay? So near to 0, okay? Like this, okay? So when it is come to this point, it will be near to 0. So your signal will be like this, okay? So I will write it here, okay? So that is how we normally draw a signal, okay? We normally draw a graph, okay? So that signal, hari මම නිකන් normally graph එකක් අඳින හැටි ඔය කට්ටියට කිව්වේ, හරි? මොකද සමහර කට්ටිය familiar, I know that some of you are not familiar with that one. So that is why I do it in basically, okay? So your signal is like this. So this will be 5, okay? So when t goes to infinity, this xt will be c, okay? So this is complex, sorry, this is exponential signal, okay? So your exponential signal is somewhat like, okay? So practically we can achieve this type of question. For example, if a capacitor is discharging, we will get this kind of shape, okay? Complex, exponential curve for a capacitor discharging curve, okay? So this kind of signals are practical, okay? So now you are going to, now what you are going to sample this signal, okay? You are going to sample this signal and your sample frequency is 100 Hertz. Your sample frequency is 100 Hertz, okay? So what that means? So if the sample frequency is 100 Hertz, what is the sampling time? Can anyone tell me? The sampling frequency is number of sample per second, okay? Sampling time means one sample time taken to get one sample. Right? Number of sample per second, fs. fs කියන්නේ number of sample per second. Right? fs කියන්නේ number of sample per second. Right? ts කියන්නේ sampling time, that is time taken to get one sample. එක sample එකක් ගන්න කාලය. එක sample එකක් ගන්න ගත වන කාලය. මේක sampling time, sampling frequency එක කියන්නේ තත්පරයකට ගන්න sample ගන්න. හරි? දැන් මේ relationship වලින් ඔයාලට කියන්න පුළුවන්. Using this relationship you can tell. So if the sampling frequency is 100, what is the sampling time? If the sampling frequency here is 100, what is the sampling time? Please tell me. මේකට උත්තර දෙන්න පුළුවන් වෙනවා. මේ sampling frequency එක දීලා sampling time එක හොයනකොටත් යම් කිසි ලකුණක් හම්බ වෙනවා කට්ටියට. හරි? ලකුණක් දෙකක් මෙතෙන්ටත් හම්බ වෙනවා. You will get 2 or 3 marks to find the sampling. Normally you are given the sampling frequency definitely, okay, for the exam. Then according to that you have to calculate the sampling time. So tell me quickly, if the sampling frequency, that means you are getting sampling frequency කියන්නේ තප්පරයකට ගන්න sample ගන්න. තප්පරයකට ඔය කට්ටිය sample 100ක් ගන්නවා නම් එක sample එකක් යන්න ගත වෙන කාලය. If you are getting 100 sample per second, what is the time taken to get one sample? I need the answer. So I think all of you should be able to answer this one. Okay, if you are touch with me. Then time make here. Sample C තප්පරයකට ගන්නවා නම් sample 100ක් එක sample එකක් ගන්න ගත වෙන කාලය. Please send me. So sampling frequency means, okay. Yes, that is correct. So what about others? I got only one answer, correct answer. Yes. Yes, but I think there is a little mistake. Okay, check the unit. Okay, now it is a time. Okay, it is a time, so it should be in second, and there is a very small mistake in the number of decimal also. Okay, please check. Anyway, that's very good. Okay, I'm just expecting the answer. Okay, whether correct or not. If it is not correct, you can identify the issue. Okay, you can identify what's your fault. If you are not answering, you can't identify your fault also. Okay, anyway. So what about others? So this means, okay, you are getting, okay, you are getting 100 sample. This is 100 sample per 1 second. Okay, 100 sample per 1 second. Okay, 100 sample per second. Okay, normally per second is referred as hertz. Okay, per second is referred as hertz. Okay, so it is 100 hertz. Okay, so hertz means per second 1 over s or s minus 1. This is hertz. Okay, number of sample per second. Okay, so 100 sample per 1 second. Okay, so what is the time for one sample? It will be 1 divided by 100, no, measured in second. Okay, so it will be 0.01 second. Okay, this is the sampling time, 0.01 second. Okay, in other words, if we consider the other way around, okay, If the sampling time is 0.01 second, that means time for taken one sample. Time for taken one sample. If you need to find the number of sample per 1 second, so you need to do this side by 1 second. That means you need to divide this side by 0.01, and this side also you need to divide 0.01 second. Okay. So now here we have the second. Okay. So you will have 100 sample that is per second. So we called it hertz. Okay. Okay, please try to understand these things. Okay. Otherwise, you couldn't answer the question. Okay. Okay. So if you couldn't understand these things, okay, that is okay. If you couldn't understand this, that is okay. What you have to do, you have to come and ask me. ඔකට මේක තේරෙන්නේ නැත්නම් කරන්න පුළුවන් හොඳම දේ තමයි ඇවිල්ලා මගෙන් අහගන්න එක. එක්ක දැන් අහන එක තව පාරක් explain කරන්න කියලා. Okay, you can ask me to explain it again, or after the session you can ask me. Okay, if you couldn't understand any point of this lecture, you can ask. You have the rights to ask. Okay. ඔයාලට මොකක් හරි තේරෙන්නේ නැති දෙයක් තියෙනවා නම් ඒකට අයිතියක් තියෙනවා කට්ටියට අහගන්න එක. හරි. මොකද මම උගන්වන දේ ඔය කට්ටියට තේරෙන්නේ නැත්නම් ඒක මගේ ප්‍රශ්නයක් වෙන්නත් පුළුවන්. හරි. Okay. Now what is means? Now the sample time is 0.01 second. That means you are getting you will take 0.01 second to get one sample. Okay, let's say that you start the sampling here. You start the sampling here. Okay, so when you are giving the question, actually this one also indicated. Okay, so assume that you begin the sampling process. You begin the sampling at t is equal to 0. Okay, so you can begin the sample at t is equal to -1, maybe at here, maybe at here. Any point the sampling can be started. Okay, now our sampling we are going to start it at t equal to 0. That means in this point. Okay, now t is equal to 0, we are getting one sample. Okay, so t is equal to 0, we are getting one sample. Okay, at t is equal to 0, you are getting one sample. Let's say that this is actually a capacitor discharging curve. So this is a voltage line. Okay, so at t is equal to 0, you just on this switch. Okay, so this is the sampler. මේක තමයි sample කරන එක. This is a sampler. Okay, this is a sampler. Okay, and you on the switch at t equal to 0. So here you can get a voltage value. So that voltage value is equal to this one, 5. Okay, so you get a voltage value 5. Okay, now again it is on. Okay, so without any time taken, it is again on. Okay, then again, so now you are getting the sample after every 0.01 second. After every 0.01 second. So you are getting a sample here. Then next sample you will get after 0.01, that means 0.02. Again you get the sample. after 0.01, that means 0.03. Again, you get the sample after 0.01, so that means 0.04. So on, you are getting sample at every 0.01 second sample. So that is the sampling time. Okay, that is 0.01 second. Okay, so you are getting sample. Okay, so at 0.01, you are getting a sample. So what is that value? To find that value, you need this graph. Okay, so when the t is equal to 0.01 second, what is your value? Xt value, x 0.01. It will be e to the power 5 e to the power minus 3 0.01. No? Okay. So using MATLAB, you can find this value. Okay. So using MATLAB or calculator, you can find. Okay. So that will be minus 3 into 0.01. Okay. So the value will be 4.85. Okay. So at this point, you will get the voltage value. You will get the voltage value. At this point, you will get the voltage value. So that will be 4.8, no? 4.85. 4.85. Again, this time also you are getting a voltage value, and there should be a voltage value, some value. Okay. So if you want to check that value, again you can use MATLAB. Okay. So it will be 5 minus 3 now 0.02. No, 0.02. That is the corresponding time value, 0.02. So you will have 4.71 something. Okay. So you will have another one, 4.71. And here also you can find the value. And here also you can find the value. Okay. Tell me what is this value. Please tell me what is this value. Use a calculator or MATLAB and calculate this value, the voltage sample of this point. Tell me this value. Use a calculator or MATLAB and tell me. Calculate. Please hurry up. මේ value එක මට කියන්න. ටග්ගල් කියන value එක කීයද කියලා. මෙතෙන්ට එන voltage value එක කීයද? 0.03 second වලදී එන voltage value එක කීයද? ටග්ගල් කියන්න. Please quickly tell me. Yes, I think that is correct. What about others? So if you try to give an answer, it will be a benefit for you, okay? It will be beneficial for you because normally I am noting the guy who give the answer. I'm not, I don't care the answers are correct or not, okay? But sometime maybe I will add some marks to them, okay? In case of if there are any low marks, sometime I add some marks to them, okay? Um, so, and also if you are given an answer, that means you are always in touch with the lecture. හරි? ඔකට මෙයාට දැන් answer එකක් දෙන්න හිතනවා කියන්නේ ඔකට නිතරම lecture එකත් එක්ක touch එකේ ඉන්නේ. එතකොට ඔකට lecture එකේ කියන දේවල් තේරෙනවා සාමාන්‍යයෙන්. පොඩි පොඩි තැන් ටිකක් හරි තේරෙනවා. ඊට පස්සේ ඊළඟ පාර බලනකොට ඔක හොඳටම තේරුම් ගත්තා හැකි. හරි සමහරට එකපාරින්ම ඔක තේරෙන්නේ නැහැ කියන එක. අනිත් එක තමයි ඔකට දැන් වැරදි ආන්සර් එකක් කියන්නේ ඔකට වැරදි විදිහට තේරුම් ගන්න අරගෙනනේ ආන්සර් එක දෙන්නේ. එතකොට ඔය කට්ටියට දැන් ආපහු හරියට එක්ස්ප්ලেইন කරනකොට හිතා ගන්න පුළුවන් ඔයාගේ වැරද්ද මේක තමයි. එතකොට ඔය කට්ටියට ඒක තව ටිකක් ඔලුවට යනවා. හරි. මිස්ටේක් එකක් වෙලා ඒක හදා ගන්නකොට ටිකක් වැඩිපුර ඒක ඔලුවට දැනෙනවා. හරි. එතකොට ඒක කියන්නේ ගොඩක් ඔකට නිකන් හරි බොරුවට හරි ආන්සර් එකක් දෙනවා කියන්නේ. නිකන් තේරෙන විදිහට වැරදි ආන්සර් එකක් හරි දෙනවා කියන්නේ. ඒක මං හිතන්නේ ගොඩක් බෙනිෆිෂල් තියෙනවා කට්ටියට. හරි. Okay, what about others? I got only one answer. What about others? So now you are getting the sample at so after 0.01 second, you get another next sample after TS second, that means 0.02. Again after TS second, sampling time, again you get the next sample. Okay, so next sample time is T is equal to 0.03. Okay, so this is the next sample time. Okay, so at T is equal to 0.03, what is X? T is equal to X 0.03 is equal to 5 e to the power minus j 3 t. This is T. Instead of this T, we have to apply 0.03. So you have to calculate this value using a calculator. Okay. So if I use MATLAB to calculate that value, instead of this 0.03, 0.02, it will be now 0.03, okay? So the value is 4.56, 4.57 actually, okay? 4.576, okay? In the same manner, you can find this sample values. So that sample is at 0.04, okay? So this value will be 0.04, okay? So using the MATLAB, I can find an example also. Okay. 0.04, okay? So now it will be 4.43. So it will be 4.43. 4.43. Same way, I am getting the sample again and again. Okay. So, so this is my sample signal. Okay. I just calculate only 1, 2, 3, 4, 5 sample. That's enough. Okay. Sometimes you are given, so in exam, you may be given the time duration of the signal. For example, you may be given sample this times, the signal duration is t is equal to 5 seconds or something. That means up to 5 seconds, the signal is there. So you have to calculate the sample up to 5 seconds. Okay. But now we are not going to do that. Okay. So we stop it here after calculating 5 samples. Okay. So this is my discrete time signal or sampled signal. Okay. Now, discrete time signal we normally not use in this time value. These are time values. No, these are corresponding time values for these samples. Okay. But for a discrete time signal, we are not referring the time value, we are just referring the sample value. So I will put this and 0 sample. This will be the first sample. So this will be the second sample. This will be the third sample, and this will be the fourth sample. Okay. So when I draw the signal, I am not referring this time value. I am just referring the sample value, that is n. Okay. So this signal is referred as xn because this signal is the function of n, function of sample number, not time. Okay. So discrete time signal is this one. Okay. But remember that this n is always related with time. Okay. For example, this first sample is 0.01. That means 1 into TS. Okay. Second sample time is 2 into TS. Third sample time is 3 into TS. In the same way, n sample time is n into TS. So that is the corresponding sample time of nth sample. Okay. So this relationship is there. Okay. So this is how we draw the signal. Okay. So this discrete signal, you normally referred in xn. Okay. Okay. And you have first sample, second, third, fourth, fifth, so on. Okay. And this will be the 0th sample. This will be the first sample. This will be the second. This will be the third. This will be fourth. This will be fifth, so on. Okay. So this will be n. So this is number of sample. Number of sample. So it can be from minus infinity to plus infinity, but including 0, but it should be an integer. Integer. Plus or minus integer. Okay. So this is our signal. Okay. So now you should be able to draw this kind of signal. Okay. Okay. Now we will go to our next exercise. Okay. So this is more important one because exam type question will be based on this sinusoidal signal. Okay. Most probably. Okay. So we will take this question. Okay. Okay. Now our signal is 2 sine 2 phi 40t. Now I have a continuous time, uh, continuous time sinusoidal signal, that is 2 sine 2 phi 2 phi into 40. Okay, so this is my signal. Okay, what is this? This is the amplitude. This is the amplitude. And what is this? Can anyone tell what is this? What is this 40? And what is the unit of this 40? Can anyone tell? Please tell me. So you know that normal sinusoidal signal is like this. To sine or cos, okay? Sine or cos, anything. The general sinusoidal signal is like this. A sine or maybe cos, okay? 2 5 ft plus 5. This also can be 2 5 ft plus 5, okay? This f is the frequency. This f is the frequency measured in hertz, okay? And this 2 5 f is equal actually omega. This omega is measured in radian per second, okay? So maybe you are given omega, or you may be given in this form also you will be given, okay? So what is this value? That means what is this value? So this is the sinusoidal signal, okay? This is a sinusoidal signal. And what is this value? What is this value? What is this? This is the amplitude, okay? This is the amplitude, okay? And this is the frequency measured in hertz. So 2 pi f is equal to omega. That is we call angular frequency or angular velocity measured in radian per second, okay? And this phi is the phase shift. This phi is the phase shift, okay? For this signal, there is no phase shift. That means phase shift is 0, okay? So what is this parameter? Is this parameter? That is the frequency, okay? That is the frequency measured in hertz, okay? Now, you need to draw this signal. That is your first task, okay? You need to draw this continuous time signal, okay? So take 5 minutes and try to draw this signal, okay? Try to draw this signal. Okay? So it will be like this, okay? So try to draw this signal. Take 5 minutes. Meanwhile, if you need, you can have a water come back, okay? So try to do this by yourself, okay? So I will explain how to do this, how to draw this kind of signal, okay? So that is very important. For your exam also, you will have to draw this kind of signal. After drawing it, you have to sample, okay? So you have to draw both continuous time version and discrete time version of this kind of sinusoidal signal, okay? So try to do it. I will come back in 7:20, okay? So please try. Okay, so how do you graph this kind of signal? Okay, so what you need to understand is that, okay, so I think you, so please remember this, okay, how you graph this, okay. So first thing is you need to remember the sine curve and cos curve, okay. The sine curve is like this. It is starting from 0, like this, okay. And this is also like this. This is a sine curve, okay. And this will be 2 5. And this will be 4 5. This will be minus 2 5. This will be minus 4 5, so on, okay. And you need to remember this thing, okay. The sine curve and cos curve. Sine and cos curve, okay. It is like this. Sine curve is like this. It's like this. Okay. Okay. So this is sine theta with respect to theta. Okay. So this is angle. Okay. This is 2, 5. This is also 4, 5. And this point is, this is 5. This is 5 by 2. And this point is 1. Okay. So this is minus 5 by 2. This point is minus 1. Okay. So you need to remember this sine curve, and cos curve is like this. Cos curve is like this because you are very often dealing with this kind of signal, sinusoidal signal. Okay. So you should have idea about the sinusoidal signal, how the signal is varying, and what is the frequency. When the frequency is changing, what happened to the signal? When the amplitude is changing, what happened to the signal? So you should have that idea. Okay. For example, our normal electricity is a sinusoidal signal, no? The commercial CB electricity is a sinusoidal wave. Okay. So this is cos theta with respect to theta. Okay. And actually this point is 5, 2, 5. Okay. Then this point is 3, 5. Sorry, 4, 5. So on. Okay. This point will be 5. And this point will be 5 by 2. And this will be 1. And this will be minus 1. This will be minus 1. Okay. So, and here this is minus 5. Minus 5 by 2. This will be minus 5. Okay. So this is 1 minus 1 and this point is minus 1. Okay. So this is a cos wave. Okay. So you should keep remember this one. Okay. Now we are going to draw our signal with respect to time, not with respect to angle. Okay. But this angle you should remember. Okay. According to the angle, your signal will be like this. Okay. Now instead of this t, you are using this one. Okay. Instead of this t, you are using omega t actually. Omega t or 25ft or 25ft. Okay. So you normally not considering this omega part to 25f part, you are drawing with respect to t actually. Okay. So, okay. So this is very simple. Okay. So if you consider the sinusoidal signal, this is one cycle. This is one cycle. This is one cycle. Okay. This is one cycle. If you using a cos signal, this is one cycle. This is one cycle. Okay. So very easily you can draw the signal if you know the frequency. Okay. So frequency is here 40. Frequency is here 40 hertz. That means what? Number of cycle per second. This is the frequency. Number of this kind of cycle per second. Okay. So that is 40 hertz. Okay. Now, if I want to find the one cycle time, how can I find it? What is the value? Tell me, what is the one cycle value? One cycle time. What is the one cycle time? How you find this? If the frequency is 40, that means number of cycle per second. That means 40 cycles are there in 1 second. So what is the one cycle value, one cycle time? What is the one cycle time? These are number of cycles. This one is called a cycle, okay? This one is called a cycle. It is called a cycle means this part is here repeating again and again repeating. So this is the cycle. This is one cycle. Now we have several cycle, repeating cycle. Okay. So one cycle time means the time taken to change the angle from 0 to 25 actually. 0 to 25. Okay. So what is the cycle time? Please give me answer. What is the value? What is the value for one cycle? What is the time for one cycle? If 1 second, 40 cycles are there, what is the cycle for one? What is the time for one cycle? Please tell me. Yes, very good. So that is correct. So what about others? තත්පරයකට සයිකල් 40යි නම් එක සයිකල් එකකට යන කාලෙ කොච්චරද? තත්පරයකට සයිකල් 40යි නම් Yes, another answer I get. That is also true. So it is very simple. සයිකල් 40කට යනවා නම් තප්පරයක් එක සයිකල් එකකට යන කාලය කීයද? මේක එක කරගන්න ඕනේ. එහෙනම් මේ පැත්ත 40න් බෙදන්න ඕනේ. You need to divide this side by 40. That means this side also divided should be divided by 40. Okay. So 40 into 40 divided by 40, it will be 1. 1 divided by 40, it will be 0.0025. So this is the one cycle time. Okay, this is a one cycle time. Now, if you draw a cycle, so sine wave is starting from here now. So if you draw one cycle like this, okay, and this time is 0.025. Okay, another cycle you can write like this. Okay. And what is this value? That is a half of a cycle. The full cycle is 25. This is 5, half of a cycle. That means that is the half of a cycle time, no? 0.025. This will be 0.0125. This will be a quarter. Okay, this will be quarter. This is 25, and this point is 5 by 2. So this will be 0.025 divided by 4. So it will be 0.00625 or something. Okay. So this time also you can calculate, this time calculate, this time calculate. So you can calculate. Okay. So this time is the second. So this will be 0.05. This time will be 0.075. So okay. And minus value also you can mark. Okay, so this is again one cycle now, so it is a minus value. So the one cycle time is 0.025, so this will be minus 0.025. This will be minus 0.05, so on. Okay, and this point also you can find, so that will be minus 0.0125. This one also you can find, half of this one again. So you can find the all time values. Okay, and so what is the amplitude? Amplitude is given by 2. So it is 2. Okay, so amplitude is 2. So this is amplitude 2, and this will be minus 2. Okay, so this is how you draw your signal. Okay, how you draw your signal. Okay, now if you put for example, if you put this 0.00625 value here, you can get the angle as 5 by 2. When you when you simplify this, you can get 5 by 2 angle corresponding to this time. Okay, so this is how we plot a sinusoidal signal with respect to time. Okay. Okay, so this is our signal. So this is very important. Okay, you should understand how we can draw it. Okay, so now if I draw it again, this, okay. Any question? So this will be minus 0.025. This will be 0.025. This will be 0.05. This will be 0.075. Okay. And this will be 0.0125. This point will be 0.00625. Six five, no? 625, yeah, 625. Okay. So these are the time values, and this magnitude, the amplitude will be 2, and this amplitude also will be -2. So this is xt with respect to t. Now we are going to sample this signal with 80 hertz. Okay. Now that means we are going to get 80 sample per 1 second. Okay. Then one sample, what is the time for one sample? What is the time for one sample? Tell me. What is the sample for one sample? What is the time for one sample? This is actually sampling frequency. Is 80. Fs is 80. Sampling frequency is 80. Okay, 80 hertz. What does that mean? You are getting 80 sample per 1 second. Correct? Sampling frequency is 80. That means you are getting 80 sample per 1 second. So what is the value for one sample? What is the time for one sample? මේවට නම් දැන් ටක් ගාලා උත්තර දෙන්න ඕන කට්ටිය හරි. දැන් මේකත් මේවා බේසික්ම ලෙවල් එක මේ හරි. Yes, thank you. Okay. So it will be, so you need to divide this by 80 and this by 80 again. Okay. So it will be 1 divided by 80. So it will be 0.0125. Okay. So this is the time to get one sample. This is the time to get one sample. 80 sample you get for 1 second. So one sample, it is 1/80. That means 0.0125. Okay. So this is the sample time. Okay. Now let's assume that you are going to sample this signal at t equal to 0. Okay. Now let's say that now you are going to start the sample at t is equal to minus 0.025. Okay. So now you are going to start the sample at minus 0.025. That means here. This is the sampling point you are going to start. Okay. Okay. That means at t is equal to 0.025, you close this switch to get the first sample. So this is the voltage value you get. Okay. Because that value, the signal value is 0 at that time. Okay. So this is the value you get at that time. Okay. Again, after 0.0127. Okay. 0.0127. That means here. Okay. From here, you calculate 0.0127. Okay. So that means you are here. Okay. You are getting again another sample. So that sample is here. Again, after 0.125 seconds, you get another sample. So it will be here. Again, after 0.125, you are getting another sample. So you are getting a sample again here. Here, here, so on, you are getting the sample. Okay. So these are the sample you get. Okay. So this is the 0th sample. This is the first sample. This is the second sample. This is the third sample, and this is the fourth sample. This is 5th sample. This is 6th sample. Now, this will be minus first sample, and this will be minus second sample. Okay. And so we normally draw this signal, this yellow color signal with respect to n, our discrete time signal. So it will be xn. Okay, not xt. Okay. So if you consider xn, if you consider xn with respect to n, so we get minus one sample, minus second sample, zero sample, one sample, second, third, fourth, fifth, sixth. Okay. So these all sample are zero. Okay. Now I think, do you have any problem up to this level? Okay, you should be able to draw this discrete time signal after sampling. Okay, so this is the discrete time signal. You sample this xt, and this is the discrete time signal. So that is the signal you get after sampling. After sampling, you get this discrete time signal. Okay, so you should be able to draw the discrete time signal definitely. That is very important. Okay. Now, another very important parameter, very important point you can figure out from this example. Okay. So I will go to our first example, this one. Okay. So you can see that, so this is our discrete sample signal. This is our sample signal. Okay. Now assume that you want to store this signal in a RAM. Okay. RAM is a digital system, digital signal. Okay, this is very important. You need to understand this. Okay. Okay. This is a digital system. Okay. RAM is a digital system. Okay. Now, if you want to store this signal, okay, up to this level, let's say that up to 0.04 second, 0.04 second, you need to store this signal from here to here in the RAM. Okay, so you know that RAM is this kind of device. Okay, so you will have some memory location like this. Okay, and each memory location have a certain number of bits. Okay, so this is the architecture of the RAM. Okay, this is the architecture of the RAM. Okay, okay, so this is a digital system. Okay, so you can see that you have finite number of memory location here. Okay, you have finite number of memory location. Okay, but if you want to store this signal, this is a continuous time signal. Okay, so from here to here, you have infinite number of uh, amplitudes level, voltage level. Okay, so this is Okay, I'm sorry. Okay. Again, I will explain. Okay, now I am telling that I need to, okay, I need to store this signal in a RAM. Okay, so this is, if you consider this signal, the capacitor discharging signal, okay, this capacitor discharging curve, okay, from 0 to 0.004 second, okay, from this time 0 to 0.004 second, there are infinite number of time value, okay, and from this point to this point, there are infinite number of amplitudes value, okay. So this is the analog signal because you have infinite number of analog, infinite number of amplitudes level between this point and this point, okay, and you have infinite number of time values between this point and this point. So this is both analog and discrete time signal, sorry, continuous time signal, okay. Now you need to store this signal in a digital RAM, okay. For example, consider Arduino board. I think you are familiar with Arduino board, all of you, okay. Now you have Arduino board. Now you want to store this signal in the Arduino board, Arduino RAM. Okay. So your signal is like this. This is analog signal now. So you have to give this signal to the analog pin. Let's say that you give it to the A0, 1, no, and this first analog pin. Okay. Now you want to store this signal in the Arduino RAM. Okay. So this signal has infinite number of amplitudes level, but this Arduino memory has finite number of memory location. So you can't directly store this infinite number of sample level, not sample level, amplitude level in this limited RAM. Okay. For that things, you have to first sample this signal using a proper sampling frequency. So that sampling frequency is decided by the Arduino oscillator. Okay. There is oscillator inside the Arduino. So the sampling frequency will be decided by this Arduino oscillator. Okay. So it has some sampling value. Now you are sampling this signal, okay, using this sampling frequency, okay. Now, after sample your signal, now you can see that we have 1, 2, 3, 4, 5, 6 voltage level. Now you have 6 voltage level and you calculate this voltage level value. This one, this one, this one, this one, this one you calculate. Okay. Now what you have to do that you have this value. Okay. So this value can be represented using 1 and 0. Okay. This is a decimal value and you can represent this decimal value using a binary value. Then you can store this sample in 6 memory location. No? 1, 2, 3, 4, 5, 6. 6 memory location is enough to store this signal. Okay. So, okay. So now I think you can understand what is the importance of this sampling. Okay. Because we can take out limited voltage value. So it can be stored in a limited memory location. Okay. Okay. So now you see that now this kind of sample we store in our Arduino board. Okay. Now let's say that now we take this Arduino board to somewhere. Okay. And again we need to get this signal out. Okay. So using this sample value, you should be able to reconstruct this signal. Okay. So you give a signal to another reconstruction circuit, then you have to reconstruct the analog signal again. So the signal should be in this way. Okay. So if I reconstruct the signal will be look like this. Okay. So you can see that it is somewhat okay, no? Up to some level, it is okay. You have the same shape from this one and this one, okay? But if you consider this signal, what happens? If you want to store this signal in the Arduino using this sample, what happened? So you get only 0 samples there. So in the memory location, you are storing only 0 voltage level. So after reconstructed, you will not get the signal, no? So it will be a 0 value. Okay. Now you can see that in this case, you can't reconstruct this signal. Using this sample, you can't reconstruct the signal. Okay. So that is very important point. Okay. So we have to, so you need to understand it very well. Okay. Okay. Give me a second. Okay. So, so try to understand this one. Okay. So I try to understand this one, and now I think we will stop. Okay. Now as a homework, now I think you can do this. Okay. Now try to sample this signal, the same signal with this frequency, with this sampling frequency, and see what happened, whether we can reconstruct it or not. Please check this one. Okay, now you are going to sample this signal with 180 Hertz. Okay, now check whether you can reconstruct or uh, whether you can't reconstruct the signal. Okay, now it is a homework you should do. And other things, okay, so you start the sampling from here. For this case, you started the sampling from here. Okay, now started the sampling in the same way, started the sampling here. If you started the sampling here, the next sample will be here. Okay, next sample will be here. Sorry, if you next sample will be here. Okay, after this sample will be here. The next sample, other sample will be here. Next sample will be again here. Okay, so consider this signal and consider the same sampling frequency 80 Hertz and start the sampling at this point. Okay, starting the sampling at this point and see what is happening, whether you can reconstruct or you can't reconstruct the signal. So that is one work. Okay, the same signal you should use with the same sampling frequency, and the sampling starting point is this one. T is equal to 0.00625. This is your sampling starting point. Okay. Okay. Then use 180 sampling frequency. Okay. So you can start the sampling at any point. Let's say that you can start the sampling point at t equal to 0. This is sampling starting point. And check whether you can get the signal or not. Okay. Okay. So we will stop. If you have any question, you can ask. Okay. Otherwise, you can leave.